Hello and welcome to day 1 of our Unit 8, which is on sequences and series. So the focus of today's lesson is going to be on arithmetic sequences. So lesson 1. All right, so first of all, what is a sequence? A sequence is formally defined as a function that has its domain as the set of positive integers. So those are your counting numbers, 1, 2, 3, and so on and so forth. A sequence is a set of terms ultimately given in a pattern. So, for example, you have a sequence over here graphically where the first term is 10 and the second term is 15 and the third term is 20 and so on and so forth. So if I even just listed those out, 10, 15, 20, 25, and I asked you, hey, what's happening each time? You would probably say, well, they're going up by 5. That's called an arithmetic sequence, which is a set of terms in a specific order having what's called a common difference. And in this case, our common difference, which I'll just call D, is 5. Now, from a graphic standpoint, if you look at this, it has a linear pattern to it. So this 5 is coming from the fact that for each one increase, we were raising 5. So if I'm rising 5 and running 1, that should look familiar. That's the same thing as a slope. All right, so for example, 25, 22, 19. Here you'd probably say, oh, well, they're going down by 3. So that means my common difference is negative 3. So yeah, your common difference can be positive, it can be negative, but it's the same thing every single time. An arithmetic sequence represents a linear function. So as you guys see, if I were to connect the dots, but I'm not, if I were to connect the dots, it would look like a line. And when I say arithmetic, another word that begins with A is adding. So think adding the same thing over and over again. So for the sequences below, we're going to define the sequence as arithmetic. If it is arithmetic, we will talk about the common difference. So take a moment, think about it. Now might be a good time to even pause the video. Okay, so let's go through these. 3, 6, 9, 12. I'm noticing that those are going up by 3. So that means this is an arithmetic sequence with a common difference of 3. B, it looks like it's going up by 2 initially, but then it gets to 8, which would be adding 4. So that's not adding the same thing over and over again. So this is not arithmetic. Now, some of you may be looking at this saying, oh yeah, you're just doubling every time. And you're right. There is a pattern. That's actually a geometric pattern that we'll talk about tomorrow, but it's not arithmetic. 1, 2, 3, 5, 8. So again, we're going up by 1. We're going up by 1. We're going up by 2. Uh-oh. All right, so that's not arithmetic. And then our last one, D. I would be going down by 4, down by 4, down by 4. Yeah, that's the same thing every time. So that is arithmetic with a common difference of negative 4. Now, let's talk for a second about C. There actually is a pattern that some of you might know. What is 1 plus 2? 3. What is 2 plus 3? 5. What is 3 plus 5? 8. So what do you think the next term of the sequence is? You said 13. You would be right, because 5 plus 8 is 13. Now, this sequence or pattern is actually called the Fibonacci sequence, and it traditionally is started with another 1, because 1 plus 1 is 2, 2 plus 3, or 1 plus 2 is 3, and so on and so forth. So, fun fact, this is called the Fibonacci sequence. due to that repeating adding of the two previous terms. It's just not an arithmetic sequence because you're not adding the same thing every time. All right, so how do we express our sequences? First is explicit notation, which is a sub n equals the formula for the nth term of the sequence. All right, I literally want you to write this in your notes, because I want you to know how to say that. Sub meaning like a subscript. That's why the n is below. So a sub n. So the n represents the number term in the sequence. So a sub 1 is representing the first term. So a sub 3 would represent the third term. Here's the good news. It's very similar to function notation. Like, you guys are familiar with f of x equals 4x plus 2. So f of 5 would mean I plug 5 in for x, and I simplify, and I get 22. In a sequence form, it's written as a sub n, though, instead, where n is the number term. So a sub 5 is the fifth term, and it simplifies exactly the same way. So the fifth term is 22. Okay, now explicit formulas are great, because if I want to find out the 78th term, I would just plug in 78 for n and it would spit it out for me. This is different than something called recursive formula, which is a formula that is based on being computed from the previous term. So a sub n represents any term, but a sub n minus 1 is your previous term. So in a recursive formula, you're going to be given two parts, the first term and then a pattern of something based on the previous term. So when you guys look at this, you should read it as, hey, if you want the next term in your sequence, you're going to take the previous term and do what to it? Add 4. So if this is my first term, to get to the next term, I'm just adding 4. So that means I would go to 9. And then I'd add 4 again. And then I'd add 4 again. Okay? But because I'm continuing the pattern based on just what the previous number is, that is coming from this recursive formula. Okay? So again, this is a sub n minus 1. Okay, moving on to the next page of our notes. So formulas for arithmetic sequences. First is our explicit formula, which is this. Which, fun fact, this is actually given on your reference sheet for this course, which means I'll give it to you for your test as well. A sub n represents any term, but a sub 1 is representing your first term. And D is representing the common difference. Now, the second way that we can express our arithmetic sequences is a recursive formula. Recursive formula always has two parts, though, and that's really important for you guys to highlight. Whenever you do a recursive formula, you have to also provide the first term. Otherwise, if something's always based on the previous term, you have to know where to start. So I give you a starting value and then what to do to move on to the next one. So this just means, hey, if you want the next term, you're going to take the previous term and add the common difference. Okay, so we're going to go through and practice how to express these in two different ways. So our first pattern is 8, 12, 16, 20, 24. So looking at this pattern, everyone should be thinking, all right, the common difference is 4. The first term is 8. So if I were to do my recursive formula, which is two parts, first term is 8. Now if you want the next term, I'm going to take the previous term and do what to it? We just said we were adding 4. So I do plus 4. That's it. Honestly, recursive I find very easy. The hardest part is just remembering how to do your notation. But if you can remember this, and then what you're doing to it, should be easy to figure out from there. Okay, so then explicit formula. Again, here's your formula. It's right up here. A sub n equals a sub 1 plus n minus 1 times d. There you go. That is your formula. Just plug and chug into it. Now, I typically leave it like this. But maybe it's a multiple choice and that's not one of your options. Something that they could do is simplify this. And they would do that by distributing the 4 and then combining like terms. So that's what? 4 plus 4n or 4n plus 4, something like that. So either one of those is acceptable, but like I said, unless I'm forced to simplify, I tend to leave it in this exact form. So moving on to the next guy, it looks like we have a first term of 5. And then I think we're going down by 3 each time. So my common difference is -3. So recursive, 2 parts. First term is 5. If you want the next term, we're going to take the previous term and do what to it? Take away 3. Explicit formula. A sub n equals a sub 1 plus n minus 1 times d. Now, notice how I am putting parentheses around d, in actually both of these cases. If you forget those parentheses, it is very common that students will think that they're subtracting 3 there, but the implied operation is multiplication, so you have to be really careful with that. So, good rule of thumb, just always put it in parentheses and then you'll never be wrong. All right, last example on this page. Looks like I am going up by 5. All right, so my first term is 15. If you want the next term, I'm going to take the previous term and add 5 to it. Explicit formula. A sub n equals a sub 1, which is my first term, plus n minus 1 times d. Done. That's my formula. So honestly, this lesson or this context right now that I'm teaching you guys, it's just really a lot of formulas and how to express these patterns. So knowing these formulas and how to use these formulas is going to be paramount in this unit. So just keep that in mind. All right, so referring to the sequence in number 3, what would be the 65th term? So the question here really is, well, how are you going to do this? Are you going to actually map out to 65 terms, or are you going to use the explicit formula to just have it spit out for you? The second thing I said is definitely what you're going to want to do. I am simply going to say a sub 65 equals, and I'm going to plug into this formula. So 15 plus 65, which is the 65th term, minus 1 times 5. And then I ultimately can just go to my calculator. Okay, so 15 plus 65 minus 1 times 5, 335. Okay, now something else I want to show you guys is just even verifying that this explicit formula matches this sequence. So if I go to y equals in my calculator and I type in 50 plus, I'll use x instead of n because that's my variable. Okay, I've now typed in my explicit formula for y1, and I'm going to go to my table of values. Let me reset it to 1. All right, there you go, guys. That x equals 1 or n equals 1 is saying, okay, the first term of the sequence is 15. The second term is 20. The third term is 25. And that is exactly matching what I have shown here. Now, for fun, let's say I want to jump to the 65th term. Okay? Now, I'm not going to sit here and just scroll. Whoa. Sorry, I made that bigger. What I can do is go to second window, which pulls up table set. Do you guys see how it says table start? I'm going to type in 65. And now I'm going to go back to my table. Look at that. Now I've jumped to 65 in the table, and it's the 335th term, which is verifying what I just did algebraically over here. So just some fun little calculator hacks to help you check yourself. Okay, now just for fun, let's reset this. Table start, I'll go back to 1. There we go. So yeah, you can jump around your table using that second window feature. All right, on to the last page of our notes for today. Jane works at the video game development company that pays her a starting salary of $100 a day, and each day she works, she earns $25 more than the day before. So how much would she earn on day 5? Honestly, the easiest way to think about this, let's just map it out. She's got $100 on the first day, right? And they said she's going up by $25 per day. So this would be $125, $150, $175, $200. So she's earning $200 by day 5. If you were to graph the growth of her salary for the first 10 days, what would that graph look like? Well, let's do a little sketch here. 1, 2, 3, 4, 5. 100, we'll say 125, 150. Okay, I think you'll start to get the idea from here. That's taking on a linear pattern, which means the type of sequence that we're describing here is an arithmetic sequence because you're adding the same amount of $25 each day. So let's now define Jane's salary using an explicit formula. So that's my formula. That's a sub n equals a sub 1 plus n minus 1 times d from our previous page of notes. All right, now let's plug in what we know. Day 1, she's earning $100. She's earning an additional $25 each day. Done. That's your formula. So now to describe it recursively, which is with 2 parts, my first term is 100. If I want the next term, I'm going to take the previous term and do what to it? Add 25. Done. That's your recursive formula. So again, knowing what I'm asking here and how to utilize those formulas, super important. Okay? Once you know that, it's actually really not that hard. All right, multiple choice. Which of the following would represent the graph of the sequence a sub n equals 2n plus 1? Now, first of all, 2 things I'm going to be eliminating here are options 2 and 4. And I'm doing that because they are connecting the dots. And by definition, if you remember, the domain of a sequence is our counting numbers. So 1, 2, 3, 4, 5, and so on and so forth. We don't have term 1.5 or term 2.25 or whatever, okay? So we're not connecting because there's not any sort of decimal or in between here. It's just the counting numbers. So those are out. Now remember what I just said. Our domain is always going to be our counting numbers. Now, if I'm being honest, there are some special circumstances where maybe they define the starting term to be at 0, but they would have to really define that for you. So we'll just say 99% of the time, it's going to be our counting numbers. So with that in mind, who's the first term? Well, a sub 1 equals 2 times 1 plus 1, just using this formula. So the first term is 3, okay? This is the one that I'm looking for. The first term is 3. Notice how this one has a term 0. Okay, that doesn't fit the domain of counting numbers because that's starting at x equals 0, so that one's out. So 3 is our answer. All right, question 7. In an arithmetic sequence, a sub 4, so the 4th term is 10 and the 7th term is 34. Write an explicit formula to represent the sequence. And I put a little reminder here that our common difference is equal to the slope. All right, let's map this out. 1, 2, 3, 4, 5, 6, 7. All right, they're telling me the 4th term is 10 and the 7th term is 34. I'm actually going to think about this in terms of coordinates like this. 4th term is 10, 7th term is 34. And I want to figure out what I'm skipping by. So going up by, that's your common difference. Now, some of you guys are going to already know how to do this because you have very good number sense, but for those of us that might need a little bit more of a formula, let's think about your slope formula, which is change in y over change in x. Okay? that would mean I'm doing 34 minus 10 divided by 7 minus 4. Okay, I'm getting 8. All right. Now, that means for every 1 increase here, you're going up by 8. So filling in some missing gaps, this is what, 18, this is 26, and then going backwards, this would be 2, negative 6, and am I getting negative 14 then? Okay. So, when I come up with an explicit formula, I'm doing a sub n equals a sub 1 plus n minus 1 times d. Okay, so just like I showed you before, let's check that. I pulled up my calculator and I typed in y1 equals, and I did negative 14 plus x minus 1 times 8. Okay, now if I go to my table of values, let's double check this. They told me the 4th term was 10, which it is, and the 7th term is 34, which it is. So now I can be confident, if I wasn't already, that this is my formula. Okay, so the slope formula will always give you the common difference. Now, some of you guys are going to think, well, couldn't I just subtract the terms and divide by the number of skips? Think about what you just said. 34 minus 10 divided by 3. Isn't that exactly what I just did here? Yes, so you're figuring out the slope without realizing you're figuring out the slope. Either way, get the common difference and show your work. All right, last question, question 8. This is a multiple choice from a Regents exam question. Given f of 9 equals negative 2, which function can be used to generate the sequence? Okay, so first of all, let's even think about what's happening here. It looks like I'm getting less negative here though, right? So I must be adding something. So I think I'm adding 0.75. Now, if you're unsure, just pull up your calculator and see if that makes sense. Negative 8 plus 0.75. Okay, plus 0.75. And I can keep doing that over and over again. Yeah, that's matching, right? Okay. So my first term is negative 8, and the common difference is 0.75. Now, if you look at my formulas, they look like some of them are starting to be in that like general explicit form. So let's do that. A sub n equals a sub 1 plus n minus 1 times d. All right, now you have to be really careful because at first glance, b looks like it, but that's a minus, not a plus. Okay, that would imply that's going down by 0.75, and that's a problem. So while b is close, it's not quite it. So my option's really not there. I'm going to have to do some cleaning up here. So notice how I'm doing some distribution. And I think I lost my n in here. I did. That should have an n on it. Okay, maybe I'll just like erase this and rewrite it. So negative 8.75 plus 0.75n. All right, let's look at our options. Looks like it's option C. Now again, you could verify that in the calculator, type it into y1, double check that it matches, and if you really want, I mean, you could double check that f of 9 equals negative 2. It will. That's honestly extra info I really didn't need, but there you have it. Moral of the story, read your notation carefully. All right, so that concludes our lesson on arithmetic sequences. Tomorrow we will pick up with geometric sequences, which are things like doubling or tripling over time. But today, arithmetic, think adding.